Okay, this lecture is for Wednesday, October 26th, 2011. Today we're going to be completing the vector lab that we had started yesterday. You'll remember that you can get those links from the side here, and if you want to refer back to the vector lab, it's right here. We're going to talk a little bit about the data that you should have gotten yesterday, along with some ways that we're going to go about graphing that data to analyze it today. The other thing that you'll be responsible for today is after I've given directions for graphing, you'll be doing that independently at your desk. I'm going to be calling you up to do a binder check. Remember, you're going to be responsible for bringing up your binder in order, so all the assignments that we've done to date in the current topic should be in order from most recent to the, the latest that we've done. And it's going to be important that you've also organized that binder according to the binder contents page that I have on my physics resources tab on my webpage. So if you're confused about doing that, there are computers at the back of the room. Make sure you get to one, you look at the binder contents page, and make sure your binder's up to snuff on how it should be. Now, we're going to go ahead and start by talking about the lab from yesterday. So we'll be clicking on this vector lab link. That'll take you to this PDF file for the vector lab. You'll remember we went out to the faculty parking lot, we picked a point, and we had people from the group measure out a distance and a direction, and we moved to that new point and we did it again. We did that 7 times, and then I had you calculate the displacement, which is the distance from the change in position from your starting point to where you finished. And some of you even got a direction with your compass, which is really good, but it wasn't necessary. So we used a meter stick and compass to do this. I had you write a procedure for what we did yesterday. Hopefully you were able to finish before you leave, but some of you took it home for homework. Remember, really important with the procedure, I'm looking for detail. I want other people to look at your procedure and be able to repeat the experiment just as you did it, as closely to the way you did it as possible. So if your procedure is very vague, then your grade's not going to be too good. It's going to be really important that you focus on making that procedure as detailed as possible so someone could repeat the measurements the way that you did it, so that they could repeat all the stuff you did as closely as possible and get the same results. A lot of you did a really good job on your data and observations. Remember here, we just had to list the vectors 1 through 7 that you took, where you put the direction along with the cardinal points. So an example would be like 60 degrees northeast, and then you would put the magnitude or the amount like 5 meters. Remember, there was a minimum of 5 meters, so all your measurements should be 5 meters and above for this. You'll have those 7 vectors over here, and then I told you that you should have written down the displacement. Today we're going to calculate the displacement by doing some graphical analysis of these vectors. So you'll be able to compare the displacement that you calculate on your graph with the displacement that you had actually gotten in the experiment by measuring it out. It'll be kind of a way for you to go back and check. So today we're going to be working with this graph paper. Now, it's going to be really important that you understand we're not going to start 0 here at the bottom left like we would normally do for a regular graph. We're actually graphing the positions that we walked outside in the faculty parking lot. So we're actually going to start 0 here in the middle initially to make sure that you have enough space going either the north, south, east, or west. So we're going to make this middle point 0. So you can actually mark it on your paper so you make sure that that's where you're starting. So that's your origin. We're going to make the top part of the paper north. So at the very top of this paper you can write north. At the very bottom you can write south, east, and then west. That way you have a reference point for all your measurements from here. All you're going to do at this point is graph out your vectors. To do that, obviously we're not going to be able to make a line that's 5 meters long here, so we'll have to make a scale, and you can do that at the bottom. You could say something like 1 centimeter equals 1 meter. That way when you're using your ruler to mark these vectors out, if it's 5 meters, well, you draw a line that's 5 centimeters long. Now, if this doesn't work, the scale doesn't work for whatever your measurements were, you could reduce that to maybe half a centimeter equals 1 meter, or even a quarter of a centimeter equals 1 meter. It's up to you, just whatever works best for your measurements so that it doesn't come off the paper. You might find that it does come off after you start. That's fine. Make sure you're using pencil. You can just erase and redo everything. with the new scale. So let's take an example here. Let's say that you were going, like I said, 80 degrees northeast. Okay, so I would get my compass, put the compass where we start on your paper. All of our compasses are see-through. We don't have a protractor, so we're going to have to use our compass to help us decide on direction. Make the compass face north, and then find 80 degrees, which should be about right here. And you'll go ahead and draw your vector out. So this would be one that was 80 degrees northeast. So I draw it out. Now let's say that the distance was 5 meters, because I said the minimum had to be 5 meters. So this is our first vector. So I'd use my ruler, measure out 5 centimeters, because 5 centimeters would equal 5 meters, according to our scale. So I'd use my ruler, I'd measure out the 5 centimeters and draw my vector. It's at an angle here of 80 degrees, which is what we measured, northeast. And then I would write out a little 1 by here, so that people would know that the first vector was this one right here. Then you'll go ahead and put your second vector. Remember, it'll start from where you finished this last one. So from here, you'll do the next vector, and you'll just keep doing them from there. Make sure you move your compass to the new point, and you actually check the degrees again and draw out your new vector. So let's say that this new vector was 110 degrees southeast. So let's do this new one, 110 degrees southeast. So 110 degrees southeast would be going down in this direction. And let's say that that was like another 5 meters. So from here, I would draw it going down 110 degrees. Notice I've gone off the paper, so obviously this scale wouldn't be one that worked for me. You'd want to change this at this point, erase everything, and make sure you reduce the scale to one that will fit on your paper without going off. Now at this point, we'd label the vector again, like I said. I'm just going to go with this to make sure everyone knows what they're doing. I'd label the vector 2 so that they knew the second vector was this one right here. And we'll list the vectors here on the side. Obviously, I'm writing a little bit big because of the equipment I'm using, but I'll expect you to write it nice and neat here on the side. You'll add up all these vectors. So let's go ahead and make some hypothetical vectors so you can kind of see what we're going to do from here. We had 7 of them. And then 7. Alright, from here what we'll do is we'll get the ruler after we've made all of our vectors and listed them, and we'll measure the displacement, so from where we started to where we finished. So we'll actually measure this distance here with our ruler. So let's say that we measure this and we find out that the displacement is equal to, as a hypothetical, 4 centimeters. Well, that would mean that 4 centimeters translates to 4 meters for us. So we can compare our displacement that we got graphically as 4 meters with the actual value that we got when we measured it outside. So the value that you wrote down your data and observation section. Whatever you have for your displacement that you actually measured, compare it with that other displacement that you got graphically. Okay, you can even use the compass to get the direction, which I would encourage you to do also, because displacement is, you need to have a direction for it. So right here you'll write down what your graphical displacement is, what your displacement was experimentally when we went outside. Again, try to include the direction for the graphical one, and then we'll go ahead and once we're done graphing this out, remember it does need to be very neat. I don't want to see lines that are all crooked and messed up. Make sure you use your ruler, draw things out. Everything should fit on the graph paper. If it doesn't, that means your scale is wrong. When you're done graphing it, you're going to come down here and you're going to write out a conclusion. Remember, the whole point of this was that we could graph out our vectors in a good way so that we could actually find the displacement. So if your displacement isn't close to what you actually measured outside, then you need to discuss that. Was there something wrong with your methods, your procedure, and address that here in the conclusion section. Alright, when you're done with this, you'll be turning it in today. It's not homework, so it's very important you finish it in class. And if you're not able to finish before you leave, that you get it in by the end of the day. The other thing is, like I said, I will be calling you up at this point for binder checks. If you're not ready for that, to turn that in, you will be getting 10 points off. You have to turn it in tomorrow. So make sure that you bring that up with you. Alright, that concludes today's lesson.